Hello friends, welcome to my YouTube channel. We have been done with chapter 1 data analysis. Now we'll be moving on to the next chapter, that is principles of actuarial modeling. Before I start the chapter and before I start with the first part of this chapter, let me move on to the contents of it. Okay. So the contents includes what are actuarial models and why they are used and how the models are used, the advantages and disadvantages of it, the stochastic and deterministic models. That is, stochastic in a sense refers to fluctuating or variable or varying observations with some given probability, and deterministic refers to fixed and constant or not fluctuating variables, discrete and continuous state space and time sets, and scenario based and proxy models. Suitability of model, which is the most important part of this topic. Short-term and long-term properties of the model, analyzing the output of the model, sensitivity testing, and communication of the results. Now moving on to the exact explanation of what are models and why they are used. So models are nothing but a proposed structure or a format to derive some predictions. Or in a sense, you can say that models are nothing but a mocking of a real-world system or process as mentioned in this slide. The applications of the model in the areas of nation's economic performance, human body functioning in terms of pulse rate, heartbeat and the future health, and cash flows of a particular organization. So models are highly applicable in the areas of nation's performance. It is also used in healthcare sector to determine a function of a human body. It is also used in financial sector where you determine the cash flows. And even it's also used in marketing sectors. It is also used in automobile sectors to come up with any engineering techniques or engineering a particular design of any vehicle. So there might be used modeling techniques extensively also. But in this field of actuarial science, we'll be dealing with financial modeling that will be dealing heavily with cash flows and varying interest rates and all. So modeling is all about predictions which may land up to be expensive, slow, or risky. Sometimes actual performance highly differs from the predicted. Yeah, it might happen that not all the time exactly your predicted values will be the same as actual performance. For example, the economy may face recession, creating an impact on elections. The patient might die and the life insurance office could suffer a surge in new business, but at highly unprofitable premium rates. So what does this mean is that no models are 100% accurate. It keeps on fluctuating in terms of real-time information. So whatever results you have derived in the past may not be the same as the current and the future. So your data's fluctuation itself will not create a full 100% error-free models. So models will have 1 to 10% of the errors. So this means if a 90% of your modeling technique is correct, which means the data is reliable and accurate. That's for sure. Now to carry out any modeling techniques, we should have proper parameters, as I have referred the Excel sheet, which I have with me for illustration to just give you a simple understanding of it. So the parameters are nothing but the inputs that are analyzed before taking the decisions of the data. Based on the decisions, we take plans that are implemented in the real world. So if you want to know the parameters, or if you want to extract parameters, you should be very clear at what is the purpose of your actuarial modeling, or what is your purpose of the modeling of a data set. So if that is clear, you will be very thorough on what all parameters are exactly required to carry on. So for these 2 points, let me show an Excel illustration which I have with me. This is the best example of actuarial model, not actuarial modeling in the sense, a simple modeling technique to give an understanding what are the parameters we use in a modeling technique considering this Excel sheet. So there is a financial calculation used known as capital asset pricing model. So for that, the parameters required to calculate this is we have an RF, beta, RM, and RF as shown. Now, what is the purpose of this modeling technique is, it is mainly applicable for the investors who want to invest in any particular stock. He want to know the risk and return of any particular assets and the market. Okay, so that will enable him to take a decision that whether he want to buy or sell any particular stock, whether he is interested to invest or whether he's not interested to invest in any particular share of a company. So this will give a proper understanding of this tool. The CAPM tool will give a proper understanding of the investors' mindset, and based on it, it will allow him to take decisions. Okay. So as if you can see, CAPM is referred to a formula as RF plus beta into RM minus RF, as I've highlighted here, where your RF is nothing but the risk-free rate of return. So best example is here is the US Treasury bond, which is a government bond. So normally government based investment products will give you risk-free returns, guaranteed returns. That is why it is denoted by RF. Whereas the required rate of return of the market is shown by RM. And beta is nothing but the relationship between two sets of variables that determines relationship. So beta is explained in terms of decimals. So here the RF of a particular treasury bond or a 10-year bond is denoted with 0.92%. The market return of the American economy is 8.54%, and beta in this case of Amazon means Amazon is a company whose share price has been referred to by the investor. So here the beta of that stock is 0.675. So considering this parameters, we have determined an equation using the CAPM model, and you substitute the value of these parameters into these variables and derive the answer. So this is how you do this is how you carry out a modeling technique. This is a very simple technique. So moving on to the third point of this, now as you would have got an idea that what are parameters, and based on these parameters, how we do a modeling of a particular set of informations. Now in the third point, as you can see in the slide, for example, we want to buy shares in a particular company. To find out the current price, we would like to have some idea of its future performance. So we could develop a model relating to the price of the shares to various factors. In our model, we might assume a fixed value for future interest rates, say 6% per annum. Okay, now this is a deterministic interest rate, as you can see here, which I mentioned here as say 6% per annum in the second last point. So this value is an input parameter as mentioned in the last point here. It is fixed within the model, but we can change it to obtain different models. So this means my rate cannot be fixed all the time. It could be fluctuating based on the real-time scenarios, changing work environment, changing policies of tax or interest rates or any company rules or investors' confidence, all the dimensions. So using this figure 6% for the time being will give us one value for the price we should pay. But we cannot be certain that 6% is a correct input, as it may fluctuate. That is, it may rise to say 10% per annum or fall to say 3% per annum. Now to build a model of a system or process, a set of mathematical or logical assumptions about how it works needs to be developed. So you will have a list of various algorithm techniques to be used. You might be using your various programming language as a tool to carry out this procedure, because every time Excel spreadsheets may not work. Then you might require some coding techniques which might save your time also, and at the same time will give more accurate results. So the complexity of a model is determined by the complexity of the relationships between various model parameters. So as you can see, the third point, the parameters sometimes or multiple parameters may not be directly related to each other, but they might be indirectly related in some form or the other. So best two examples that explains this slide is modeling a life office. Consideration must be given to issues such as regulations, taxation, and cancellation terms. So life office means a life insurance based company where you will be dealing with a lot of policy holders, where they will be paying premiums to the company for which they will be getting a claim amount at the maturity period. So there the premium rate which is to be fixed for the policy holder will depend on the policyholder's age. It will depend upon the taxation rules of the government on insurance companies. It will depend upon the fluctuating interest rates and so on. This is the best example. The next example is future events affecting investment returns, inflation, new business, lapses, mortality, and expenses also affect the relationship in any insurance or pension firms or any directions. Now, as I explained about parameters, let us move on to data. So in order to produce a model and determine suitable parameters, data needs to be considered and judgments needs to be made as to the relevance of the observed data to the future environment. That is the live environment in this sense. Now, such data may result from past observations, from current observations such as inflation rate, or from expectation of future changes, which means your data should be related to the past, present, and the future performance. So all the three dimensions should be linked to a data set. When observed data are considered to be suitable for producing the parameters for a chosen model, statistical methods can be used to fit the data. If you remember, in the first chapter, I discussed about EDA. If you recollect, EDA means explorative data analysis, where I explained about three different methods of it, and that was descriptive, inferential, and predictive. So what are these? These were the statistical methods which were heavily used, right? So these you'll be covering in depth even in your CS2 or CS1 module for actuarial papers. So for example, as if you can see the fourth point, for example, if we were to model the daily changes in the price of shares in a particular company using a normal distribution, then the parameters would be the mean and the variance. We could estimate these by looking at past data and calculating the sample mean and variance. These would be sensible estimates. So these you will be dealing in depth in CS1, as I said. Now, when we're done with parameters and data, we move on to the objectives, which actually should have been the first step of determining a data structure or determining any sort of modeling techniques you carry. So objectives means what? It's a purpose. It is important to consider the objectives for creation and use of the model before moving ahead. We look for the costs and risks involved rather than preferring accuracy. Sometimes there might be a case. If you look at the second point, I can just explain you in simple words. Developing a faith towards 100% accurate model data will not be always safe, because as I said, there might be huge risks and cost involved in determining it. For instance, there were some, let us consider that not actuarial modeling in the areas of financial modeling. Basically, every company had some kind of objectives or some kind of agendas to derive forecasting techniques of their business. So they used to come up with projected financial statement, that is a forecasted financial statement for the next 10 years. And slowly and gradually, with the changing technologies and government policies and customers' preference, their forecasting business techniques reduced to the duration of 5 years, 4 to 5 years rather than 10 years, because there was a huge risk of predicting the future performance for a decade. That was not possible, because the technology used to change things rapidly in every directions. So there, the accuracy which was used, or accuracy which was derived by some modeling techniques based on the 10 years data set didn't work for a long period of time. So that brought down the forecasting of any business performance to 5 years rather than doing it for 10 years. So this is the best example that I can explain about setting up objectives for any modeling a data set. So the next point is, the third point is, moreover, we need to decide what the best model is within the context of its intended use. For example, we might wish to model the number of claims made to an insurance company for various amounts. So you will have different good and excellent alternative models in your hand, of which you have to select the best. You would have come up with some 4 or 5 models, of which is accurate, which is demanding, which is having a huge scope, which is user friendly and at the same time which is applicable in multiple data sets or in multiple purposes also. So that will be determined as a best model. So we might wish to model number of claims made to an insurance company for various amounts, as the example is very well mentioned here. How models are used? While in reality, a modeling process does not follow a rigid pattern of prescribed steps, it is helpful in introducing the topic to imagine a set of key steps. In practice, actuaries who build and use models move back and forth between these key steps continuously to improve the model. So actuarial science is a place where there will be a severe modeling techniques used. It is not just auditors or chartered accountants who will be doing this, but actuarial science is also having that concepts. The 14 steps in a modeling process that can be described as follows. So modeling process have various steps and procedures, and that is altogether have 14 steps. So if you remember in data analysis, which I taught in the first chapter, we dealt with the 9 steps to be carried out in a data analysis process. Here almost the same steps are used, but with little bit of elaboration and extension of it. That is why it's coming up to 14 steps. But almost each and every step are the same, which you have covered in the first chapter. So let us look at each and every step of it. So the first step is develop a well-defined set of objectives that need to be met by the modeling process. So as I said, you have to have the purpose for modeling. Second step, plan the modeling process and how the model will be validated. Third step, collect and analyze the necessary data for the model. So we had primary data or secondary data source. Either primary data, you will have a survey, feedback form, questionnaires and interviews, and secondary data will refer to already published data set in your internet or newspapers or magazines. Fourth step is define the parameters as I explained in the previous slides for the model and consider appropriate parameter values. Define the model initially by capturing the essence of the real world system or the live data system, you can see. Refining the level of detail in the model can come at a later stage. What is refining? Like you deal with missing observations, treat extreme values, get rid of them, clean it and see to it that you don't have any flaws in the data set so that it will be fit for modeling. Next step is involve experts in the real world system you are trying to imitate to get feedback on the validity of the conceptual model. So you will get negotiations with the experts to deal with the data. Next step, decide on whether a simulation package or a general purpose language is appropriate for the implementation of the model. Choose a statistically reliable random number generator that will perform adequately in the context of the complexity of the model. So you could come up with some software that will automatically generate some random numbers that will be compatible for carrying out modeling techniques. So rather than coming out with your own set of models or numbers, it may or may not give accurate results. So the random number generated by the software itself might be convenient enough. So you can move ahead. That will be self-reliant to carry out any modeling techniques. Write the computer program for the model as shown the next step. Debug the program to make sure it performs the intended operations in the model definition. So what is debug? Debug means remove omissions or errors which is coming in your way whenever you are passing any kind of algorithms in computer programming. Like you have Python, R programming, or any sorts of Java or SQL. These are the computer programming languages which you use to carry out any sorts of data analysis or modeling techniques. The next step is test the reasonableness of the outputs of the model. Once you have assigned variables, assigned parameters, checked and refined the data, now move on to the analysis part, framed an equation that will be the basis of your modeling, do the modeling, apply the modeling techniques on your data set, then strengthen the accuracy of the data. Based on it, you derive the output of the model and test the reasonableness as shown in the step 10. So whatever I explained now is up till step 10. Now moving on to the step 11 is review and carefully consider the appropriateness of the model in the light of small changes in input parameters. Okay, so you have to be very careful that in case any minor changes are required, you have to be taken care. The 12th step is analyze the output from the model. analyze the output very carefully. It might happen that your output may not be relevant or your output may not show a good result. So either you could have come across some parameters which you have not considered or you have disregarded, or either you have to eliminate some parameters which is irrelevant in the data set or discard them to reduce unnecessary complexity of the data, or you can reduce the intensity of confusion. The next is ensure that any relevant professional guidance has been complied with. For example, the Financial Reporting Council has issued a technical actuarial standards on the principles for technical actuarial work known as TAS 100. So this is a list of guidelines which is being developed by the IFOA body or the UK body in the grounds of actuarial science. So if you go to the website of IFOA, you will come to know about the TAS framework that explains each and every aspects of your professional ethics, career goals, and what is your how you should perform each and every task, how you have to coordinate your informations of all the actuarial works which you do, and how you have to avoid duplication or copying of the work and come up with your own research work by referring to some key points, how you interpret the results to the user with valid notes. All these factors are considered under TAS 100, which is a guidelines of framework given. The next is communicate and document the results and a model. So finally, you will come up with a full-fledged, finished, documented informations in terms of graph, diagram, pie chart, the profile of your task, which all expert panels are involved in this activity while we're doing the modeling techniques, what all different alternatives you had kept with your hand in case if one method didn't work. Okay, and you have come up with fluctuating or fixed variables, etc., etc. So these were the steps of your modeling techniques. Now moving on to the advantage and disadvantages of model. In advantages, we will find that in actuarial work, especially, one of the most important benefits of modeling is that systems with long time frames, such as the operation of a pension fund, can be studied in compressed time. Other benefits include using complex systems with stochastic elements. So stochastic means fluctuating elements. Example, simulation modeling is a way of studying the operation of a life insurance company rather than using logical mathematical model which is not capable of producing results. So simulation modeling, in the sense, any predictions which you make based on a real-time data or a live data, if that model is accurate or perfect, that you can use it for multiple purpose rather than coming up with your own logical equations or models which is running in your mind based on some assumptions. You can avoid that kind of what we say, dummy equations or any sorts of assumed criteria based equations. You can get rid of it rather than pick up a real data and do the modeling techniques. Different future policies or possible actions can be compared to see which best suits the requirements or constraints for user. So these were the advantages of your models. And what are disadvantages? Models are not the simple solution to all actual problems. They have drawbacks that must be understood when interpreting the output from a model and communicating the results to clients. The drawbacks of modeling requires a considerable investment of time and expertise. The financial cost of development can be quite large given the need to check the validity of the model's assumption, the computer code, meaningful results, and simple interpretation. So financial cost of development, in the sense you'll be having different softwares which might be applicable to carry out any set of predictions or carrying out an analysis or coming up with some mathematical or machine learning algorithms and all. So let us give a very simple example that you have some lot of visualization tools running in the market for analyzing a data. Say we have Tableau, which is a visualization technique. But some multinational companies, rather than using Tableau, they use a substitute of that software tool, which is known as Power BI. that Power BI is doing the same visualization activities as what Tableau is doing, but the features, the screen, the configurations are a bit different compared to the Tableau features. So you'll find that whenever you apply for a job in a company, they ask for Power BI rather than asking for Tableau. But you are very specialized in Tableau, you cannot apply for that particular job. So there, each and every software has its own unique feature because the financial cost is being referred to by the company to use that software. So there they are trying to economize or use cost saving techniques or prefer those software which is cheap enough or easy enough to understand. So that explains what we say, the financial cost of development in this case. So here the drawbacks of modeling, as I said, the financial cost of development can be quite large given the need to check the validity of the model's assumptions, the computer code, meaningful results, and simple interpretation. In a stochastic model, for any given set of inputs, each run gives only estimates of a model's outputs. So to study the outputs for any given set of inputs, several independent runs of the model are needed because it's a stochastic model. The model which have its variables or parameters keeping on fluctuating. I'm sorry, not the parameter. I mean to say the variables which keeps on fluctuating. So this normally requires a repetition or iteration of the model to be run several times again and again to derive different outputs. Now it is useful for comparing the results of input variations than for optimizing your outputs. This means you have to check your input variables whether they are relevant or reliable and accurate enough to determine your outputs. Models can look impressive when run on a computer, so that there is a danger that one gets lulled into a false sense of confidence. As I mentioned, rather than looking at the accuracy of the model, you have to associate with the cost and risk related to the models, as I explained in the previous slides. Model has to pass test of validity and verification. If not passed, yet it may look impressive when run on a computer, but it will not represent or denote the real world or the live data system. Models rely heavily on the data input. If the data quality itself is poor or lacks credibility, then the output from the model is likely to be flawed, which is a very true and most common feature or common disadvantage of modeling. There is a danger of using a model as a black box from which it is assumed that all results are valid without considering the appropriateness of using that model for the data input and the output expected. So you derive any particular results from a model which have some data inputs which may not be practically relevant, or the input might be an outdated or based on an outdated set of informations, okay, or the input would have been taken from some secondary sources which is also not correct or accurate. So there we have to tally and cross verify by asking your experts or negotiate with your team leaders, with the superiors, to know exactly how you can get rid of this black box situation. Okay, so it is not possible to include all the future events in a model. For example, a change in legislation could invalidate the results of a model, but may be impossible to predict when the model is constructed. So let me give a simple example here. 10 years before, any organizations or firms were not able to predict that in year 2020 there will be a COVID or there will be a pandemic. So those future events cannot be even predicted. They cannot be even thought of. That future events cannot be included because future itself is uncertain. So there, a change in any activity might be disregarded if that, or it may not be included if that future event is not affecting any particular task or any particular modeling or any data modeling which you are carrying out in an organization or in your particular career. So these were the advantages and disadvantages of your actuarial modeling. So we'll move on to the part 2 in the next video sessions. So by the time, please don't forget to subscribe and comment on my YouTube channel, and please share this. Thank you.